A warm welcome to the third film in our roof waterproofing series. In it, we explain how a cold roof is constructed. Once again, we will start with the example of a reinforced concrete slab, even though timber roofs are frequently also cold roofs. Here, the first layer of the cold roof is laid on the flat concrete surface. This first layer acts as a vapor retarder. As the term implies, this layer is not intended to prevent all water vapor from entering the concrete structure and the interior of the building, as in the case with a vapor barrier, but merely to reduce and regulate the passage of water vapor into the insulating material. An impermeable barrier is not required because, as we will see later on, the top of the insulating layer is ventilated, thus allowing water vapor to evaporate. Insulation is then laid on this vapor retarder, as for a warm roof. In this case, the insulating material used is generally mineral wool laid in strips between the ceiling joists. The top of the insulation may be protected by sarking or another liner, as for a pitched roof. Roof sheathing in the form of timber planking or wood composite decking boards is then fitted over the insulation, leaving a gap. This gap ventilates the roof structure above the insulation, allowing any moisture from the interior of the building to evaporate. This distance between the insulation and sheathing is created by making the joists higher than the insulation or installing battens on top of the joists. The water-bearing waterproof layer is then laid on the sheathing. This can again be a bituminous or plastic membrane placed in a single or double layer. Once again, the membrane must be fitted without any breaks or leaks, and the joints between the sheets are sealed using an adhesive or by torching. Since the sloping waterproof layer cannot be produced by the use of tapering insulation panels here, it must be created at either the ceiling slab or the joists. Although there are systems in which the waterproofing is fixed to the sheathing, it's common to weigh down the loose waterproofing membranes with a ballast of gravel, other aggregate, or a growing medium, in the case of a green roof, in a manner that resembles the construction of warm roofs. This type of construction is called a cold roof because the waterproof membrane is laid on the cold side of the roof. The temperatures above and below the membrane are almost identical due to the ventilation gap beneath the sheathing. The insulating effect of the layered structure ends at the top surface of the insulation, with the water-bearing layer running exclusively on top of the waterproofing. Summary. The first layer of a cold roof, called a vapor retarder, is laid on the load-bearing reinforced concrete or timber roof structure. The insulation is then placed on this vapor retarder. Roof sheathing in the form of timber planking or wood composite decking boards is then fitted over the insulation, leaving a gap which ventilates the roof structure above the insulation. A water-bearing waterproof layer in the form of a bituminous or plastic membrane is then laid over the sheathing. The waterproof membrane is generally secured by means of ballast such as gravel or a growing medium in the case of a green roof. This type of construction is called a cold roof because the waterproof membrane is fitted on the cold side of the roof. Why not go on to watch the fourth film in our roof waterproofing series? In it, we take a look at inverted roofs.